All right, parallel lines is what we are going to talk about today. Parallel lines are lines that are always the same distance apart and will never intersect. Basic definition of parallel lines. Most of you are familiar with that definition. These two lines are parallel. They have the same slope. Parallel lines have the same slope. I need you guys to have both of these things in your notes. The equation for the green line is y equals 3x plus 4. The equation for the blue line is y equals 3x minus 5. Both of these lines are parallel because they both have a slope of 3. All right, next part of your notes are these three graphs. This is what your note should look like. So let's take the first set of notes in that first box. So once again, parallel lines have the same slope. These lines we can clearly see both have the same slope. Both of them have a slope of negative 1/4. And we can see that they are both parallel. They will never cross. They will never intersect. They will keep on going and going and going forever and ever and ever. They are both parallel. They both have the same slope. Notice, same slope, different y-intercepts. These lines, also parallel. They both have the exact same slope of 2/3. When we graph them, the green line will look like this. The blue line will look like this. The green line intercepts the y-axis at -1. The blue line will intercept the y-axis at -4. These slopes are different. This line has a slope of 2/3 and the blue line has a slope of 5/3. These lines will intersect. And we can see that they intersect right there at 3,1. If we were graphing this if we were writing the solution to this system of equations, that solution would be 3,1, the point where they intersect. Next section of notes. Write down these two equations. -1/2 x minus 2, -1/2 x minus 1. Parallel lines. Now, we're going to just see why these lines aren't going to cross. We can see that for the green line, I'm just going to graph this line, and I can graph it off the page forever and ever and ever, and I can do the same with the blue line, graph it off the page forever and ever and ever and ever, and we're seeing these lines aren't even approaching each other at all. They're just getting further and further and further, they're just going further and further back, and their distance apart is staying the exact same. They're not leaning into each other. They're not leaning away from each other. They are staying the exact same distance. That distance is never going to change. Next section of notes. These two lines. -1/2 x minus 2, -1/4 x plus 3. These lines, they have different slopes. This one has a slope of -1/2. This one has a slope of -1/4. Right now, we can see that these two lines are kind of leaning into each other. They're not slanting with the same type of slope. They're slanting toward each other. And here, if I go backwards, we're going to see that they're not going to intersect over here, but over here, we're going to find that they intersect. So I can go the other way. And I can do the same with the blue line. And these lines aren't going to intersect on here, but we can keep on going. And eventually what we are going to find is that these lines will intersect. It's going to take a while, but they eventually do intersect. They intersect at this point right there. That's where those two lines cross. So recap, they started over here. This was their y-intercept, and they crossed all the way over here. So here we see lines with the same slope. We can graph them forever and ever, and they never intersect. And lines with different slopes will eventually intersect, even if it is way off the graph. They eventually do intersect. These lines are parallel, not parallel. All right. Will the lines for the equations below be parallel? Those are their graphs. They have the exact same slopes. Both of them have a slope of 3. They will be parallel. How about these guys? These guys have different slopes, therefore they will lean into each other. They will cross eventually right there at -2, 2. Not parallel. These guys, be careful on this one. Think about if these are both in slope-intercept form, and if not, make sure that you change it into slope-intercept form. All right, so these lines, if we, this line isn't in slope-intercept form. We have -y or -1y. I can write that invisible 1 in. And if I get positive y, if I put this line into slope-intercept form and divide each term by my number in front of my y, -1, I'm going to find that I'm going to get y equals positive 3x plus 4. Now, when I look at my two lines both in slope-intercept form, I can see that they both have a slope of 3. Therefore, they will be parallel. How about these? I'm going to do the exact same thing I did with the other equation. I'm going to put this into slope-intercept form, and when I do, I'm going to divide each term by 2, and I'll find that I'll get y equals 3x, 6 over 2 is 3, plus -8 over 2 is -4. So now I have my two lines. They both have the exact same slope, and they are both parallel. How about these guys? These, when I divide, or when I put the other equation into slope-intercept form, I find that this one, y equals 4x, 8 divided by 2 is 4, plus 4 divided by 2 is 2. These lines have different slopes. First line has a slope of 3, second line has a slope of 4. When I graph them, they look like this. They intersect at 0, 2. These lines are not parallel. All right, let's find the solution to these. So next, turn to the back of your paper. These are where we're going to take these notes. So for the first set of equations, I'm just going to graph them like normal. This line has a y-intercept of -4. It goes up 7 and over 4. The other line below has goes through the y-intercept at 1, goes up 1 over 2, up 1 over 2, and they eventually intersect at 4, 3. Now these lines are parallel, and we know that a system of equations has a solution where the two lines intersect. We know that lines with the same slopes are parallel, and lines that are parallel never intersect. So same slope, they're parallel, which means that they will never intersect, which means that there is no solution to this system of equations. When lines are parallel, they have no solution. Next section of notes. Find the solution to this system of equations. Here, we have y equals 3x plus 2 and y equals 3x plus 2. These lines have the same exact slope, but they also have the same exact y-intercept. So here, make sure that all of this is written down in your notes. Here, since they have the same exact slope, we would think that they were parallel, but they also have the same exact y-intercept. So when we graph these lines, we will notice these equations are the exact same. The orange line, when graphed, will look like that. And because this blue equation is the exact same, the blue equation is also going to intercept the y-axis at 2, and will also will also have a slope of 3 over 1. So my blue line looks like this. They are the exact same lines. They're right on top of each other. So for the solution where the lines intersect, well, they intersect here, and there, and there, and there. They intersect here.
Jacqueline Castellanos, please report to the front office. Jacqueline Castellanos, please report to the front office.
Okay, yeah. Okay, they intersect here, 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 here. Oh my God, they intersect everywhere. These equations, same exact equations, intersect everywhere. there are infinitely many solutions, infinitely many places where they intersect. So, summarize what we learned here by just filling in the blank with the appropriate letter. And in Khan Academy, you are going to go and work on this objective, graphing systems with 1, 0, or infinite solutions. When you are finished with that, if you are not finished with the objectives that we were working on the other day about graphing the systems of equations, finish up that. I'm taking grades for that tonight. Tonight is the last night to make up grades, so make sure that you have all of that done so that you get the grade that you want on your report card.